Section 3.1, Reference Angles. In this section, we will look at the reference angle definition and theorem, and also approximations. Definition. The reference angle or related angle for any angle theta in standard position is the positive acute angle between the terminal side of theta and the x-axis. The reference angle theta is denoted by the theta hat. To calculate the reference angle, recall the reference angle is always greater than 0 degrees, less than 90 degrees. For any theta in quadrant 1, the difference of the x-axis and the terminal side is the same as the theta. Therefore, the theta hat or reference angles is the same as the angle theta. In the second quadrant, the theta hat is from the difference of the terminal side and the closest x-axis. The closest x-axis is 180 degrees. So the theta hat is 180 degrees minus angle theta. If the theta is located in the third quadrant, the theta hat or the reference angles is the difference between the closest x-axis, which is 180 degrees, and the terminal side. Since the terminal side is in the third quadrant and the angle is greater than 180 degrees, theta hat is the angle theta minus 180 degrees. For the theta in the fourth quadrant, the theta hat or the reference angles is the difference of the x-axis, which is 360 degrees, and the angle theta. More example here. Theta equals 30 degrees in quadrant 1. Therefore, the theta hat and the theta is the same, or the reference angle is the same as an angle theta. In quadrant 2, the theta is 135 degrees. Theta hat or the reference angles is the difference of the closest x-axis and the angle theta. Or the reference angles is 45 degrees. The theta equals 240 degrees located in the third quadrant. The reference angle is the difference of the terminal side and the x-axis, and the closest x-axis is 180 degrees. Theta hat or the reference angles is 240 degrees minus 180 degrees, or 60 degrees. In quadrant 4, the reference angles is the difference of the closest x-axis, which is 360 degrees, and the angle theta, which is 330 degrees for this example. The reference angles is 30 degrees. For the negative angle, we calculate the same way. We see the difference or the difference of the reference angle, the difference between the terminal side and the closest x-axis. In this case, the theta is negative 210, which is 30 degrees beyond the closest x-axis, which is 180 degrees. Another example of the negative angle, negative 140 degrees, which is located in the third quadrant. And then the reference angles is the difference between the terminal side and the closest x-axis. Negative 140 degrees is 40 degrees more to get closer to the closest x-axis, which is negative 180 degrees or 180 degrees. Therefore, the reference angles is 40 degrees. More examples. Draw the following angles in standard position and then name the reference angles or the theta hat. Theta equals 48 degrees. This one is in quadrant 1 or the first quadrant in the standard position. So the theta hat or the reference angles is the same as an angle theta, which is 48 degrees. Number 2, the theta is 130 degrees, which is located in the second quadrant. Therefore, the theta hat or the reference angles is the difference of this angle and the closest x-axis, which is 180 degrees. So the reference angles is 180 degrees minus 130 degrees or 50 degrees as the reference angle. Number 3, theta is 340 degrees in the standard position. The terminal side is located in the fourth quadrant. Therefore, the theta hat is the difference between the closest x-axis, which is 360 degrees, and the terminal side, which is 340 degrees. So the reference angles, or the theta hat, is 360 degrees minus 340 degrees, or 20 degrees. For the negative angles, theta is negative 125 degrees. In the standard position, negative 125 degrees is located in the third quadrant. So the reference angles, the theta hat is the difference of between the closest x-axis and also the terminal side, which is 180 degrees minus 125 degrees, or 55 degrees. Number 5, the theta is 400 degrees in the standard position. It goes counterclockwise beyond one revolution, which is 360 degrees, and then it's finally located in the first quadrant. The theta hat or the reference angles, which is the difference of the terminal side and the closest x-axis. The closest x-axis is 360 degrees. So the reference angles for number 5, or for the angle theta equals 400 degrees, would be 400 degrees minus 360 degrees, which is 40 degrees. To find the trigonometric functions of angles between 0 degrees and 360 degrees, the step 1, we find the reference angle, the theta hat. Step 2, determine the sign of the trig function based on the quadrant in which the theta terminates. Step 3, write the original trigonometric functions of theta in terms of the same trigonometric functions of the theta hat or the reference angles. Step 4, or the last step, find the trig function of the reference. For example, to find the exact value of each of the following functions. Number 1, the cosine of 240 degrees. The theta is 240 degrees. It is in quadrant 3. The quadrant 3, and then find the theta hat. The theta hat in quadrant 3 is calculated by the theta minus 180 degrees. Therefore, the reference angles is 240 degrees minus 180 degrees, or 60 degrees. For the cosine of 240 degrees, recall all students take calculus. In quadrant 3, only the tangent and the cotangent will be positive. So the cosine will be negative inside. The negative cosine of the theta hat or the reference angles. So negative cosine 60 degrees will be the same as the value of the cosine of 240 degrees. Use the exact value table. The cosine 60 degrees is 1 over 2. Therefore, the cosine of 240 degrees is negative 1 over 2. Number 2, the secant of 315 degrees. The angle theta is 350 degrees, which is located in quadrant 4. In quadrant 4, the reference angles can be found by the difference of the closest x-axis or 360 degrees and the terminal side, which is 315 degrees. So the reference angles for 315 degrees is 45 degrees. Next, we're going to use the sign in quadrant 4 for the secant. From the diagram, all students take calculus. In quadrant 4, the cosine and the secant will be positive. So we're going to calculate the secant of the reference angle, which is 45 degrees. The secant 45 degrees is 1 over cosine 45 degrees, which is 1 over square root 2 over 2, and returns 2 over square root 2, which is the same as square root 2. Next part, the angle is 150 degrees. We are going to find the tangent of 150 degrees. Theta equals 150 degrees, which is located in quadrant 2. In quadrant 2, the reference angles is the difference of the closest x-axis, which is 180 degrees, and the terminal side, which is 150. Therefore, the reference angles of 150 degrees is 30 degrees. Next, use the sign of the tangent in quadrant 2. In quadrant 2, the sign of the tangent is negative. And then find the value of the tangent of the reference angles or the tangent of 30 degrees. From the table, the exact value, the tangent of 30 degrees is 1 over square root 3. Therefore, the tangent of 150 degrees is negative 1 over square root 3, or negative square root 3 over 3. The last one, sine of negative 210 degrees. An angle theta is negative 210 degrees. If you sketch the diagram real quick, this is a negative angle. It goes clockwise from the initial side, and then the terminal side located in the second quadrant. The theta hat or the reference angles is the difference between the closest x-axis and the terminal side. The closest x-axis is 180 degrees. So then the theta hat is 30-degree difference of negative 210 and 180 degrees. The sign in the second quadrant is positive. Then the sign of negative 210 degrees is positive in sign of the sign value of 30 degrees, which is 1 over 2.